This is SpaceTime Series 25, Episode 118. Coming up on SpaceTime, the Mars Curiosity Rover reaches a key target on its climb up the red planet's Mount Sharp. NASA orders more Orion Spacecraft for manned Artemis missions to the Moon. And in one of the few signs of cooperation with the West following the Kremlin's invasion of Ukraine, Russia has launched a Progress cargo ship full of supplies for the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity Rover has finally arrived at a long sought-after target on its journey climbing the foothills of the red planet's Mount Sharp. The car-sized six-wheeled mobile laboratory has reached an area believed to have formed when the red planet's climate was drying up, turning Mars from a warm, wet world where life could exist into the inhospitable freeze-dried desert it's now become. To reach this area, known as the sulfate-bearing unit, Curiosity's had to traverse a narrow sandline pass. In fact, it took the rover more than a month to safely navigate this treacherous terrain, which snakes between high hills and is lined with sand dunes which could bog the rover's wheels, potentially causing it to get stuck if the wheels lose traction. And the hills themselves block Curiosity's view of the sky, requiring the rover to be carefully oriented based on where it could point its antennas towards the Earth and how long it could communicate with orbiters passing overhead. Scientists hypothesized that billions of years ago, streams and ponds left behind salt-enriched minerals as the water in this sulfate-bearing unit dried up. Now, assuming this hypothesis is correct, these minerals offer tantalizing clues as to how and why the red planet's climate changed from being more Earth-like to being the strange, inhospitable world it is today. These minerals were spotted by NASA's Mars Reconnaissance Orbiter years before Curiosity landed in Gull Crater back in 2012, so scientists have been waiting a long time to see this terrain up close. Soon after arriving at the sulfate-bearing unit, the rover discovered a diverse array of rock types and signs of past water. Among them, popcorn-textured nodules and salty minerals such as magnesium sulfate, calcium sulfate, including gypsum, and sodium chloride, which to you and me is ordinary table salt. They selected a rock they named Kenema for the mission's 36th drill sample, and choosing it was no easy task. See, along with science considerations, the team also had to factor the rover's hardware after more than a decade on the surface of the red planet. The thing is, Curiosity uses a percussive or jackhammer-style rotary drill, the end of its 2-metre-long arm, in order to pulverize the rock samples for analysis. But warm brakes on the arm have recently led the team to conclude that some of the harder rocks may require too much hammering to drill safely. So mission managers first brushed away the dust and then simply poked the top of the surface of the rock with the drill. The lack of scratch marks or indentations was an indication that this rock may prove to be a bit too difficult to drill. However, using a new drilling algorithm designed to minimize the use of percussion, mission managers decided to proceed anyway, and as it turned out everything worked out fine and no percussion was needed. Curiosity is slowly working its way up the foothills of Mount Sharp, a 5.5-kilometre high central peak in Gull Crater. The mountain appears to be an enormous mound of eroded sedimentary layers, deposited like a geology history book describing the area's mineralogy and climate. This report from NASA TV.
The terrain around the Curiosity rover is beginning to look very different. The rover has driven over 16 miles since landing in Gale Crater in 2012. We're climbing the side of Mount Sharp, 1,500 feet above our landing site, a very tall mountain in the center of the crater. We spent the last several years investigating clay-rich rocks that formed in lakes. But now we're entering a region where rocks are filled with salty minerals called sulfates. These minerals form in drier conditions, so we think this area might show us how the ancient Martian climate was changing. We're starting to see lots of very cool, knobbly textured rocks. We think these veins and nodules were created by groundwater. Here we recently drilled our 32nd sample of the mission, By studying the chemicals and minerals in this rock, we can learn how the ancient environment was changing as we go from the clay region into the sulfate region. And these hills are different from anything we've seen on the lower mountain. They're rounded, unlike the ridges and mesas we've seen before. We'll soon be entering a narrow valley that should make for some amazing images. This changing terrain is more than just fun to look at. It can teach us how Mars lost its water over time. How long did conditions that were favorable to life last? We're looking forward to finding out.
This is SpaceTime. Still to come, NASA orders more Orion spacecraft and a food run to the International Space Station. All that and more still to come on SpaceTime. NASA has ordered 3 more Orion Crew capsules from Lockheed Martin for future Artemis manned missions to the Moon. The $1.99 billion deal will provide spacecraft for the Artemis 6, 7 and 8 missions to the Moon, taking the agency through to the 2030s. The Orion spacecraft will use European Space Agency-built service modules and fly on NASA's SLS launch vehicles. The Artemis program is designed to establish a sustainable human presence both on the lunar surface and around the Moon through the Gateway space station, which will act as a base camp for excursions down to the lunar surface. The program's longer-term aim is to develop the sorts of skills needed to get humans to Mars by the late 2030s or early 2040s. Notice how that date keeps rolling back. The first mission in the program, Artemis 1, is now slated to launch aboard an SLS Super Heavy Lift rocket on November the 14th, carrying an unmanned Orion capsule around the Moon and back again, splashing down in the North Pacific Ocean. It'll be the second flight for the Orion capsule, which undertook its maiden test flight aboard a Delta IV Heavy rocket back in 2014. That 4.5-hour flight took the Orion spacecraft on 2 orbits of the Earth, reaching a peak altitude of 5,800 kilometers. Now, if the Artemis 1 mission goes to plan, Artemis 2 will launch in 2024, carrying a 4-person crew around the Moon and back. And if that works out well, Artemis 3 will launch in 2025, carrying a crew to lunar orbit, where 2 of those people will transfer to a pre-positioned SpaceX Starship HLS, which will then transport them down to the lunar surface near the Moon's south pole for what will be a week-long stay. Artemis missions 4, 5 and 6 will deliver modules and equipment for the Lunar Gateway space station, as well as lunar rovers for surface operations on the Moon. Artemis missions 7 through to 11 will deliver more equipment for Gateway, as well as habitats and logistics modules for the lunar surface. NASA's current plans would see 12 Orion spacecraft built through to the early 2030s, by which time the Artemis program will be relatively mature. Current orders mean that 6 Orion capsules have either been built or are ready to be delivered, meaning 6 more are yet to be ordered. With the Artemis 1 Orion spacecraft currently on top of the Space Launch System rocket ready to fly, 2 more Orion capsules are now undergoing final assembly at NASA's Kennedy Space Center in Florida for the Artemis 2 and 3 missions. Work's also well underway on the Artemis 4 spacecraft, including welding the pressure vessel together at NASA's New Orleans facility and building the heat shield at Lockheed Martin's Denver facility. And construction's also just commenced on the Artemis 5 Orion vehicle. Lockheed Martin says the Artemis 2 spacecraft will use selected avionics from the Artemis 1 crew module, and that reuse will continue to dramatically increase, where the Artemis 3 pressure vessel capsule will be entirely refurbished for the Artemis 6 mission.
Orion is NASA's next mission, next spacecraft that's going to take astronauts out into deep space. Unlike some of the current commercial cruise systems that are being developed that are taking astronauts from Earth up to the space station and back, Orion's actually going to take astronauts back out into deep space. This is something we haven't done since 1972 with the Apollos. They went to the Moon. Orion's going to go much further, asteroids, even to Mars. Orion is basically a capsule design. It has anywhere from 4 to 6 astronauts can fly in this crew module area of the spacecraft. It's solar powered, so it uses the solar electricity to power all of its computers. Service module area behind the crew module is where the propulsion, where the large oxygen tanks would reside, the various engines that help it maneuver when it's in space. When it comes back to Earth, it has to go through the Earth's atmosphere. It's very thick, it's coming at an extremely high rate of speed, and so it has a heat shield, and the crew module will actually detach from the service module, turn around and come back, and that heat shield will slow it down substantially. Somewhere in the neighborhood of more than 90% of its speed will be scrubbed off. It's then used parachutes. So Orion is designed to go out into deep space, much farther than we've ever traveled before as humans. Mars, ultimate destination. So when humans go to Mars for the first time, it's going to be using the Orion spacecraft. We're going to probably have 4 astronauts. They'll have a very international component. This is a spacecraft along with a large habitat system attached to it. They'll take astronauts all the way out to Mars and back.
Yes, my name is Lee Morin, MD, PhD, and I'm an astronaut mission specialist. With Orion, America is building a new spacecraft for exploration. Could involve missions to the moon, missions to an asteroid, missions to Mars, and we want Orion to be able to do all those things, to take 4 astronauts into deep space and return them safely to the Earth. And the goal was to build a cockpit user interface, a dashboard, so to speak, that would allow the crew to control that spacecraft for that period of time for these deep space missions, and to have the flexibility so that even if they were away from the planet for months or even years, that they would have the information they needed to fly that vehicle and return safely to the Earth. And the concept was to go with a glass cockpit, and what that means is that the instruments are all images on a computer screen. They are all on the glass. So rather than flipping a physical switch, the crew brings up a computer screen and flips a virtual switch, a little icon of a switch or icon of a valve. And with the exception of 7 panels right around the computer screens, which have about 60 switches, that is all of the cockpit of Orion happens on the glass. One big benefit is a weight savings, because you don't have to have a physical switch. And having a physical switch, not only is there the weight of the switch, but you also have the weight of the wire to the switch. And you have to have the weight of circuitry that takes that wire and feeds it into the vehicle computers. By putting that on the computer screen, you save that weight and you save the complexity of those wires. That gives us a lot of flexibility. And as we work with the cockpit, if we find certain ways that we could do it better, it's perhaps easier to update the software than it is to rewire the vehicle. It's been very exciting to see the Orion and the cockpit come together, and to see the computer software that I've helped write and my colleagues have been writing come together. And think that these are the screens that the first crew that goes to an asteroid will be looking at to help them control the vehicle. These are the screens that the first humans who go to Mars will be looking at as that mission unfolds in the decades ahead. The Orion is going to be the linchpin of humanity's exploration beyond low Earth orbit into deep space. I get a chill thinking about the role that I've had and the privilege I've had to be able to participate in that.
This is SpaceTime. Still to come, a Russian Progress cargo ship carrying fresh supplies successfully docks to the International Space Station. Scottish company Skyrora fails in its first space launch attempt. And the constellation of the winged horse Pegasus, the giant galaxy M31 Andromeda barreling towards the Milky Way, and 3 meteor showers in the 1 month are among the highlights of the November night skies on Skywatch. A Russian Progress cargo ship has successfully docked to the International Space Station's Poisk module 2 days after launching aboard a Soyuz 21A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The Progress MS-21 is carrying over 2.5 tons of supplies for the 7 Expedition 68 crew on station.
Launch Site 31 at the Baikonur Cosmodrome in Kazakhstan, the Progress 82 vehicle running through final procedures, ready to begin its 2-day 34-orbit journey to deliver cargo to the International Space Station. Everything's still running smoothly. We're now in the phase of pressurization of the fuel tanks. The booster tank is now being pressurized for flight. That pressurization optimizes the flow of fuel and helps add structural support to the rocket. The Soyuz rocket is now on internal power, and we have an auto sequence start. Separation of the first umbilical tower. The launch command has been issued. The engine start command has been issued. We have an engine ignition. Turbo pumps are building up to flight speed. And liftoff. Liftoff of Progress 82, the next vehicle in the supply chain to the International Space Station. Good roll, pitch, and yaw. Program reported from Baikonur. First stage performance reported to be nominal. Good chamber pressure reported on the first stage. Good vehicle stabilization reported. 1 minute and 15 seconds into flight. Everything reported to be going well. Standing by now for first stage separation.
Параметры конструкции ракеты-носителя в норме. Тангаж, рыскание, вращение в норме.
Flight controllers reporting everything operating nominally, and the launch shroud has jettisoned. The Soyuz booster traveling at almost 5,000 miles per hour. The second stage will last until about the 4-minute and 47-second mark into flight. All of the vehicle parameters reported to be nominal. Standing by now for second stage shutdown and second stage separation. The third stage engine is up and running. Everything looking good. Now traveling just over 9,500 miles per hour and 100 miles in altitude at the 5-minute mark into the flight. Now being propelled by the single engine of the Soyuz third stage, the engine will thrust and burn for about 4 minutes. Good third stage engine performance reported. All structure parameters still reported to be nominal. Third stage performance continues to be solid, propelling the Progress 82 cargo craft into its preliminary orbit. 6 minutes and 38 seconds into flight, third stage engine still burning nominally as the Progress heads towards its preliminary orbit on its journey to the International Space Station. 7 minutes and 30 seconds into flight, the Progress and the Soyuz now traveling 14,000 miles per hour, 124 miles in altitude, the trajectory flattening out, about 1 minute of powered flight remaining. Third stage performance still reported to be going nominally. Now at the 8-minute mark into flight, since the Progress lifted off, Progress now traveling almost 15,000 miles per hour and 125 miles in altitude. All structure parameters still reported to be nominal. Third stage shutdown confirmed and the spacecraft separation confirmed. Next step will be the deployment of the solar arrays and navigational antennas on Progress 82. And now getting reports from the Mission Control Center in Koryov that the solar arrays and antennas have deployed. The Progress 82 resupply spacecraft now officially in its preliminary orbit, which begins its 2-day journey to the International Space Station to deliver about 3 tons of cargo.
Included in the manifest are 702 kilograms of fuel, 428 kilograms of drinking water, as well as fresh food, clothes, and hygiene equipment. The mission and the International Space Station program are one of the few areas where collaboration between the West and the Kremlin's continuing despite the ongoing Russian invasion of Ukraine. They say space is hard, and Scottish company Skyrora has learnt that lesson the hard way after the maiden test flight of their new Skylark L suborbital launch vehicle failed to reach space. The Embraer-based company attempted to fly its 11-metre-tall rocket off an Icelandic launch pad in the country's northeast. However, the booster fell into the Norwegian Sea just 500 metres downrange. Skylark L was designed to reach a maximum altitude of more than 125 kilometres, flying at over Mach 4. The vehicle was designed to test equipment and procedures for the larger Skyrora XL rocket, slated for launch from the United Kingdom next year. The company completed a key engine test of Skyrora XL's second stage in August, in what was the largest test of its kind in the UK in more than half a century. This is SpaceTime. Time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. November is the 11th and penultimate month of the year in both the Julian and Gregorian calendars. It retained its name from the Latin Novem meaning 9 when January and February were added to the Roman calendar. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian Etruscan mythological winged horse who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are the spectral type M red stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then a Roman numeral is added to the end of all that to represent luminosity. Now, put all that together and a star like our Sun is known as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As for Epsilon Pegasi, well, it's estimated to have about 12 times the mass of our Sun and about 185 times the Sun's radius. Epsilon Pegasi, together with the stars Markab, Al-Janib, Sjeet and Alpha Andromedae, form the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked-eye stars shaped like a huge square in the sky. One of the stars in the constellation is 51 Pegasi, which was the first main sequence star beyond our Sun to be discovered to host a planet. 51 Pegasi is a Sun-like star located 50.45 light-years away. Its planet, or more accurately exoplanet, meaning extrasolar planet, is designated 51 Pegasi b. The exoplanet's discovery was announced on October 6, 1995 in the journal Nature. It was detected using the radial velocity or so-called wobble method with a spectroscope used to detect very slight but regular Doppler shift changes in the star's spectral lines caused by the gravitational pull of the planet pulling the star one way and then the other as the planet orbits around it. 51 Pegasi b is about half the mass of Jupiter and orbits around its host star every 4 Earth days at a distance of just 7 million kilometres. At the time, a gas giant orbiting so closely around the star was something that had never been seen before, and this led to the creation of a new category of planets known as hot Jupiters, a category of gas giants thought to have formed further out from their host stars beyond the so-called snow line, but which then migrated inwards towards their current positions. The discovery led to the realization that the gas giants of our solar system, Jupiter and Saturn, also migrated inwards closer to the Sun during their early formation, something which explains many of the features of our own solar system, including the late heavy bombardment, the asteroid belt, and some unique characteristics of the ice giants Neptune and Uranus, as well as the mass distribution of the 4 inner terrestrial worlds, Mercury, Venus, Earth and Mars. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located about 33,600 light-years away. Globular clusters are tight spheres containing thousands to millions of stars, all originally formed at the same time in the same molecular gas and dust cloud. Many are thought to be the cause of small galaxies that have been cannibalized by larger ones. Our own Milky Way galaxy contains at least 150 globular clusters. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains an estimated 100,000 stars, making it one of the most densely packed globular clusters in the Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars which appear to be surrounding what may well be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars, including one double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're away from city lights, you may notice a fuzzy patch in the sky right next to Pegasus. And that is the majestic giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in the local galactic group. It's located some 2.5 million light-years away. Estimates suggest it contains over 1 trillion stars, twice that of the Milky Way, and is some 220,000 light-years across. Now, if you can't see it too well, don't worry, it's getting closer every day. You see, the Milky Way and Andromeda galaxies are expected to collide in about 3.7 to 4.5 billion years from now, eventually merging to form what will be a new giant elliptical galaxy. Another case of galactic cannibalism in action. Now, based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also appears to have far less new star production than the Milky Way producing about one new solar mass star every year. And the rate of supernovae in the Milky Way is also about double the rate of Andromeda. Andromeda is surrounded by a large and massive halo of hot gas, estimated to contain about half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That means it reaches almost halfway out to the Milky Way. Now, using a good pair of binoculars or a small backyard telescope, you'll even get to see the dust lanes in Andromeda's spiral arms and its bright central galactic core, which contains a monster supermassive black hole. Now, located slightly to the east and south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. Beta Ceti, or Deneb Katos, is the brightest star in the constellation Cetus. It's an orange giant located about 96 light-years away. By the way, that name Deneb Katos, well, it means the whale's tail. One of the other stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 Earth days, changing in diameter from about 400 to 500 times the diameter of the Sun. Alpha Ceti, traditionally called Menkar, the nose, is a red-hued giant star some 220 light-years away. Now, it's actually a double star system, with the secondary star 93 Ceti being a blue-white star some 440 light-years away. Another double star is Gamma Ceti, the head of the whale. The primary is a yellow star 82 light-years from Earth, while the secondary is a blue star. At 11.9 light-years away, the yellow dwarf Tau Ceti is the nearest sun-like star to the Earth other than the Sun. Okay, looking south of Cetus now, and you'll see the brilliant star Achernar, which means the river's end, as it marks the end of the river Eridanus. Eridanus is the 6th largest of the modern constellations, and the one that extends furthest in the sky from north to south. Achernar is a binary system, and the primary star Alpha Eridani actually consists of 2 stars, Alpha Eridani A and B, located some 139 light-years away. Of the 10 brightest stars in the night sky, Alpha Eridani is the hottest and bluest in colour. That's due to Achernar being a spectral type B blue main sequence star. Achernar also has an unusually rapid rotational velocity, causing it to become oblate in shape. The second star in the system is a smaller spectral type A white star, which orbits the primary at a distance of about 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or just over 8 light minutes. Now, if you follow Eridanus towards the east, you'll find the constellation Orion, a familiar signpost in the southern summer and northern winter skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova back on the 4th of July in the year 1054. They recorded the sudden appearance of a new star on their sky charts at exactly the position of the Crab Nebula. Their records show the supernova appeared brighter than the planet Venus for weeks on end, before finally fading from view after about 2 years. The shock wave from the Crab Nebula's supernova explosion is continuing to blast outwards, expanding at a rate of about 5 million kilometers per hour. At the heart of the nebula is a rapidly spinning neutron star, a pulsar, rotating at some 30 pulses per second. As it rotates, it shines a beam like a lighthouse beacon sweeping across the galaxy. This beam emits radiation at all wavelengths from gamma rays and X-rays right through ultraviolet, optical and infrared, even into the radio waves. Observations indicate the pulsar is slowing down and will fall to just half its current rotational rate in the next 1,000 years. November is also a great time to check out the Pleiades or Seven Sisters, one of the nearest open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus the Bull and are composed mostly of hot blue-white stars. Now, depending on whose measurements you prefer, the Pleiades are somewhere between 118 and 137 parsecs away, a parsec being around 3.26 light years. The amazing thing about the Pleiades is that different cultures from vastly different parts of Earth have all described the Pleiades in the same way, as 7 women or 7 sisters. And this could possibly be some sort of ancient throwback to early human out-of-Africa civilization. Just like October, November sees 3 meteor showers. There's the November Orionids, the Taurids and the Leonids. Although peaking in late October, the Orionids are continuing to sprinkle down during the start of November, and are usually at their best during the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter. The Taurids' meteor shower are generated by the comet Encke, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Encke and the Taurids are believed to be the remnants of a large comet which disintegrated between 20 and 30,000 years ago, breaking into several pieces and releasing material both by normal cometary ablation and also occasionally by close gravitational encounters with the Earth and other planets. In fact, the cometary stream of material left by Encke is the largest in the inner solar system. Being so spread out, the Earth takes several weeks to pass through it, causing an extended period of meteor activity compared to the much smaller periods of activity of other meteor showers. And further gravitational interactions with Jupiter have caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to November the 25th, while the northern Taurids go from October the 12th to December the 2nd. But the Taurids do have their downside. They're quite diffuse, usually only producing about 7 meteors an hour. However, they are composed of more massive material. Think of pebbles instead of dust grains. And so they tend to produce a high percentage of very bright meteors known as fireballs, produced as larger meteoroids burn through the atmosphere. The southern Taurids put on their best show just after midnight on November the 5th. Finally, there's the Leonids meteor shower, which will peak on November the 18th. The Leonids are usually pretty reliable with 15 meteors an hour. However, they have been known to occasionally produce spectacular meteor storms, with showers in 1999, 2001 and 2002 producing an amazing 3,000 Leonids meteors an hour. Even more spectacular was the Leonids meteor shower of 1966, which generated thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. They're produced by the debris stream from the comet Tempel-Tuttle. And as their name suggests, the Leonids radiate out from the constellation Leo the Lion. The Leonids are a fast-moving stream, which encounters the path of Earth at 72 kilometres per second. Larger Leonids, which are about 10 millimetres across, can have a mass of half a gram and are renowned for generating bright meteors. Scientists estimate the annual Leonid's meteor shower deposits between 12 and 13 tonnes of particles across the planet every year. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the November night skies.
G'day, Stuart. November night skies. Well, if you go out in the evening in November time, well, at least where I am in the southern hemisphere, we're coming onto summer, you'll see the Milky Way. It's hugging the western horizon, actually. Often you see the Milky Way sort of stretching directly overhead depending on the time of night and the time of the year. This time of year, at this time of night, you'll see the Milky Way hugging the western horizon. And you've got the tail and the stinger of Scorpius still sticking up over the horizon. You've got Sagittarius nearby. Sagittarius, when you look in that direction, you're looking towards the centre of the Milky Way. So constellations like Scorpius and Sagittarius, for people in the southern hemisphere, they're winter constellations, and they're summer constellations for our friends in the northern hemisphere. And when you see them disappearing over the western horizon, you really know that the seasons are changing and we're getting towards the end of the year. If we go sort of around to the right from looking west, so we're now looking north, the northern half of the sky, for us looks pretty bare. It's filled with a bunch of big constellations that have very few bright stars. There are constellations like Pegasus, which is the winged horse. You've got Pisces, the fish, Cetus, the whale, Aries, the ram, and a big long one called Eridanus, the river. Now, you'd never pick this, of course. It's just a join the dots affair, and it stretches halfway across the sky. So that's what's in our northern half of the sky. For our friends in the northern hemisphere, you're looking to the south, of course, and you'll see those ones. A couple of interesting things you can see in this part of the sky. If you have very dark skies, I mean, like really dark, and you let your eyes adapt to the dark, you might be able to see the Andromeda Galaxy. For people where I live in Australia, it's very low on the northern horizon, so some people actually can't see it because it's below the horizon. But if you're far enough north, the Andromeda Galaxy is up over the northern horizon a bit. And if you've, as I say, if you've got really dark skies and you're dark adapted and you don't have any lights around, you might be able to see this galaxy. And it's an actual galaxy, and it's a long, long way away. It and the Triangulum Galaxy and the Milky Way make up the three largest galaxies in what's called the local group, which has lots of other member galaxies, but they're all pretty small and, I was going to say insignificant, less significant we'll call them, although I'm sure it doesn't seem that way to the people who live there, assuming people live there. But yeah, if you can spot the Andromeda Galaxy with the naked eye, that's basically the furthest thing you can see, pretty much, with the naked eye in the universe. It's beyond stars, it's beyond anything. It's another huge galaxy, about the same size as ours, long, long way out in there in space. So see if you can give that a try. Over in the eastern sky, we've got the constellation Orion. It's starting to poke its head above the horizon. This is really good because it means that for us in the south, the summer is coming along, the good weather and the nice stargazing evenings. For our friends in the northern part of the planet, of course, it means winter's coming along, so things are cooling down up there. If you're trying to find the Southern Cross and you can't spot it, don't worry, it's there. You don't need glasses or anything. It is there, but during the evening hours of this time of the year, the cross is upside down and it's very low on the horizon, down the southern horizon for most people. For some people, it's even below the horizon. If they're far enough north, they can't see that far south. So it depends where you are. From where I am, well, I've got houses and things that block my view to the south, down that far south, down near the horizon. But if I leave it till later on in the evening or in the early morning hours, the Earth will have rotated and the Southern Cross will make an appearance again. It'll be on its left-hand side about a third of the way up from the horizon if you go out in the sort of early morning hours. And the two pointer stars are nearby, of course, Alpha Centauri and Beta Centauri. Alpha Centauri was the destination for the Jupiter 2 with Dr. Smith and the family Robinson and the robot, you babbling booby, that kind of thing. The pain, yeah. From Lost in Space. What a great TV show. So, early morning hours, if you're an early riser or you stay up really, really late, you'll see the sky has changed quite a lot, in fact, as the Earth has rotated and it's brought new constellations up into view in the east. Other ones have gone down in the west. You'll see that Orion now is really quite nice and high in the northern sky, or the southern sky for our friends in the north. You've got the constellation Canis Major with its bright star Sirius, which is the brightest star in the sky. And you've got constellations like Gemini and Leo and Cancer. They're all visible there for us in the northern half of the sky. And if you've got a telescope or a pair of binoculars, you sweep through some of those constellations, you can see lots and lots of really nice stuff in terms of star clusters and some nebulae and things. Gemini is an interesting constellation. In mythology, Gemini is the constellation of the twins, and indeed it does have two bright stars, Pollux and Castor. Pollux is the brighter of the two. It's a giant orange-coloured star about 34 light years away, which means it's a fairly standard sort of star, and it's not too far away. Castor, on the other hand, when you look at it, it seems to be one star, but it's actually a group of 6 stars, all very close together, all in close proximity. And it's a bit further away, about 51 light years. but it still appears bright because two of those six stars are actually bigger and brighter than our sun. This is an interesting thing to think about when you look up and you see the stars in the night sky. A lot of them belong to multiple star systems, whether it's a double star or a triple star. Sometimes it's 4, 5, 6. So when you look up there and you think, oh, that's a beautiful star, there might be actually two up there. And some of them you can actually pick apart with a telescope. If you've got a telescope, backyard telescope, you can actually see that one star is actually two. It's just that to the naked eye, we can't quite see that sort of detail.
That's the most common type of star in the universe, multiple star systems.
Yeah, that's right. And you know, stars are thought to be born out of big swirling clouds of gas and dust, and they form multiple stars at once. And multiple stars at once will form in a particular area is the most sort of common scenario. Sometimes those stars will drift apart. Other times they'll stay together. So our star, the Sun, is single star. It's a lone star. And we've got our nice little solar system going around, all the planets. And so for a long time, astronomers thought, you know, there are multiple stars out there. Could they have planets? Would you have planets in stable orbits going around one or two stars that are very close to each other? And a lot of people said, yes, you could. Other people said, no, you can't. It turns out, from the evidence we've got now, yes, you can. So, the multiple star system scenario is the very common one out there in the cosmos. And it looks like you can have planets in those multiple star systems as well. So there you
just
go.
Look at our nearest neighbour, Alpha Centauri, 3 stars.
Yep. Alpha Centauri is a double star system. You can see that through a telescope. And of course, there's a third star called Proxima Centauri, which is a little way away, but is thought to what's the latest? I think it is thought to still be the
it's orbiting around the
third
other
member,
two.
isn't it? Yeah. So that's another thing too. That for a long time they weren't really sure was Proxima Centauri part of the Alpha Centauri system or not. But better technology we have now, better telescopes, better measurements and things, they can start to answer some of these questions. Speaking of planets in our solar system, we'll talk about the planets now, what we can see. So just like last month, Mercury, very low on the horizon and hard to see during November. In this case, though, it's the western horizon after sunset rather than the eastern horizon before dawn, as it was in October. So if you're lucky, if you've got a very flat horizon, you don't have trees and houses and hills and things in the way, after the sun's gone down, you might see what looks like a little bright star on the western horizon. That's probably Mercury. Venus is out of sight for most of November because it's been around the other side of the sun from us for quite a while, therefore lost in the solar glare. It will start to reappear above the western horizon after sunset at the end of the month. So if you go out after sunset, like right after sunset, and you look to the west, you see a bright star-looking thing, like really quite bright. That's Venus, and it'll slowly climb higher and higher in the sky as each night passes, as the weeks go on from that. Planet observers are getting pretty excited at the moment because Mars is getting closer and therefore appearing a bit bigger through their telescopes. It's actually going to be at its closest to us for a couple of years on December the 1st. And a week later, it's going to reach a point called opposition, where it's in one direction in the sky and the sun is in the other direction. So opposite directions are seen from Earth, and that's the best time to view Mars, when it's close to us and it appears a bit bigger through a telescope. You can find it in the eastern sky after sunset. Just go out there, look to the east, and you'll see an orangey-red star. Not a star, of course, and about medium brightness, and that is Mars. The two biggest planets, Jupiter and Saturn, you can see them in the evening sky. Jupiter's to the north, as seen from the southern hemisphere, and Saturn is to the northwest. So for our friends in the northern hemisphere, that means south for Jupiter and southwest for Saturn. They're pretty easy to spot because they're really nice, big and bright, particularly Jupiter. And finally, there's going to be a total eclipse of the moon on the evening of November the 8th in Australasian time zones at least. There'll be different time zones for other people around the world. So for North America, for instance, it's going to be morning time on the same date, November the 8th. This will be a pretty good eclipse too. Totality is going to last for 86 minutes, and the moon will probably go a dull reddish colour. This is because although the Earth is blocking direct sunlight from shining on the moon because the moon's in the Earth's shadow, some sunlight does sneak through the edge of the Earth's atmosphere and is refracted or bent onto the moon, towards the moon. And it's the red wavelengths that get the refraction the most, are refracted the most. So that means that the moon goes a bit of a red colour. Sometimes it can be quite vivid. Sometimes it's a dull sort of colour. It just depends on a few things, including what's happening in our atmosphere. So go out and have a look, November the 8th. And, of course, being an eclipse of the moon is perfectly safe to see. Don't have to worry about any sort of eye protection like you do during a solar eclipse.
And,
there
of course,
you go.
because there's a lunar eclipse, that means there must be a solar eclipse happening somewhere in the world too.
That's right, Stuart, yeah. 2 weeks apart. You get eclipses of the moon and sun 2 weeks apart. So the eclipse in this case, the paired eclipse, was 2 weeks before, on the 25th of October. That was a partial eclipse of the sun, and it was visible across Europe, Middle East, Northern Africa, and Western sort of Asia region. But this one will be a total eclipse of the moon, and it'll be on November the 8th.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.